All right, I welcome you all to today's tutorial. So for everybody that will be coming in, thank you so much for joining us in this live session. Okay, without wasting much of our time, we'll go straight into the tutorial. Okay, today we are going to be looking at complex number. That we are going to be looking at. Okay, so if you are joining us, thank you so much for joining us today. So let's go straight into the business of the day. We only have a limited time. Okay, we'll be looking at so that is what we are going to be looking at for today. Now, when we say complex number, there are basically two things that should come to your mind. Now, when you hear complex number, this should come to your mind. We have that z is equals to x plus I y. So this thing should come to your mind once you hear complex number. Why did I say that? It's because complex number actually comprises of two numbers. We have real numbers, there are different kind of numbers. We have real numbers, we have rational numbers, we have irrational numbers. So, but complex number is also another type of number. Okay, so complex number contains of two types of number, which are real number. So the real number used to be the x1. So this is the real number. This is the real number. Then we now have the y part, which is the imaginary number. Okay, so which is imaginary. So actually so this one, they are the imaginary. So we have the x, which is the real part, then iy, which is the imaginary part of the complex number. So but the imaginary number itself is the I, and this I is actually gotten from the square root of -1. So square root of -1 is equal to I. So it was Euler when he was trying to solve the quadratic equation, and he solved the quadratic equation, and he came across the square root of minus. So it was not like how is he going to represent this minus? Because if you press your calculator, the square root of negative of any number is sign error, like it doesn't exist. That kind of number does not exist. Understand? So that's why I now came up with this strategy. So and let me show you how it works. Let's say, for example, you are solving a quadratic equation and you end up with, let's say, for example, you end up with x equals to, let's say, -6, then plus or minus square root of, let's say, -36, for example, then divided by 2. Now, if you, on recess, like if you use your calculator, if you want to solve this is literally impossible to do. So, but you can actually simplify it by saying that x is equal to -6 plus or minus. Then you can split it. If you are good at sort, you can say square root of -1 multiplied by the square root of 36. It's still the same thing. Then divided by 2. So now you see this square root of -1. That is how complex number actually came into place. Then you can have something like x is equal to -6, then plus or minus. We can simply represent that square root of -1 as I. Then what is that? Square root of 36, which is what? 6. So that is simply the basis of complex number. So in complex number, you can perform different kind of operations with complex number. You can perform addition, you can perform subtraction, you can perform multiplication, you can perform division. So today, I did a video on some basic functions, operational functions um, on on operations of complex number, and I'm going to give the link out so that you can get the video and watch. So, but today we'll just look at the application of those or let me say today's tutorial is relative to the previous ones I did. So I'm going to just take some questions, you know. All right, so let's dive into questions. Yeah, let's dive into questions and solve some questions. Okay, let's assume that you have that z1 is equal to z1 minus 5i, and you have z2 equals to 2 minus 3i. If you have something like this, it's very easy, and you have to perform some basic operation like addition, subtraction, multiplication, and division. So let's start with addition. For example, let's say you have to perform z1 plus z2. This is a good one. So now you notice this is your z1, which is 7 minus 5i. So you simply write 7 minus 5i, then plus, that's this positive sign here, plus z2, which is 2 minus 3i. Can you see it now? So then what you simply do is that. Now, if you are doing this kind of operation, we have the real part of a complex number, and we have the imaginary part of a complex number. So the real part goes with the real part, and the imaginary goes with the imaginary. That is how you do it. Okay, so when you look at 7 minus 5i, what is the real part? The real part is 7. And when you come here again, the real part is what? The plus 2. Then here we are going to have minus 5i followed by minus 3i. So 7 plus 2, that's 9. Minus 5i minus 3i, of course, that's 8i. So simple. It's just as simple as that. Yes. Let's take z1 minus z2. Let's also do this. If you have to perform operation like z1 minus z2, it's very easy. First of all, you write your z1, that's 7 minus 5i, then minus, you open the bracket. Then what's your z2? The reason we open a bracket is because, minus is not like plus. It's actually, it will have effect on the sign. So you have to just put it in bracket. So it's going to be 2 minus 3i. Let's open the bracket. 7 minus 5i minus 2 plus 3i. Yes. This is going to be minus 2. Minus times multiplied by minus is going to be plus. And we have a 3i. So which is going to be. Now, again, we take the real part will go with the real part. And imaginary will go with the imaginary. So we're going to have 7 minus 2 minus 5i plus 3i, which is going to be 5. 5 and this is going to be, of course, minus 2i. So it's as simple as that. So that's how simple it is. Okay, let's take multiplication, for example. Let's look at multiplication. Okay, let's take multiplication. I hope you all can hear me. Okay, for multiplication, which is going to be z1 multiplied by z2. So we have 7 minus 5i into 2 minus 3i. Now let's, if you are used with, if you are conversant with quadratic equation, this should not be hard, but if you are not, so I'm going to break it down for you so that in case you come across problems like this, you know how to do. So the first one is you pick this 7, anything you have, you pick it. You open a bracket, then you write everything here, you write it inside the bracket. That's 2 minus 3i. You close the bracket, then you pick the remaining, well, that's minus 5i into 2 minus 3i. Let's see now. Then at this point, you open the bracket. 7 times 2 is going to be 14. 7 times 3i is going to be minus 21i. Then minus distance is going to be 10i. 10 plus 15i squared. Okay. Then we are going to have 14 minus 21i minus 10i plus 15. Now, don't forget that I squared is minus 1. I squared is minus, and I'm going to show you how I squared is minus 1. Look at this. When we have that I is equal to the square root of minus 1, right? So now, taking the square root of both sides, you are going to have I squared is equals to square root of minus 1, and then we're also going to square this one too. So we have this, then which means that your I squared, I squared is equals to minus 1. So that's how we have this minus 1. Then we're going to have 14 minus, you notice that minus is common, and okay, 21i minus 20, 21i minus 21i minus 10i. That should give you 31i. Then plus times minus will give you minus. 15 times 1 will give you 15. Then which is going to be 14. So you take the real part to the real part and imaginary. So just like normal remains 14 minus 15, then minus 31. So what do you have? You're going to have 14 minus 15 is minus 1 and minus 31. So simple. That's how to do it. Okay. All right. Let's take another example. Okay. Now, okay, so let's do z1 divided by z2. So for z1 divided by z2, we can definitely have z1 divided by z2. So what's z1? z1 is 7 minus 5i over 2 minus 3i. Okay? When you have something like this, there's something called rationalization in sort. Okay? So you can also rationalize in complex number too. So this is how you rationalize. What you simply do is that you multiply both the numerator and the denominator by the denominator, but you just change the sign in between. So let's say we have 7 minus 5i divided by 2 minus 3i. So how do you rationalize? You just say times 2 plus 3i over 2 plus 3i. That's it. So let's continue. So you numerator will multiply numerator, denominator will multiply denominator. So the way I've taught you, just say 7 into everything there, that's 2 plus 3i, close the bracket, then minus 5i into 2 plus 3i, close the bracket, divided by, that is 2 minus, that's going to be 2 into 2, let me clean this. So which is going to be 2 into 2 plus 3i, close the bracket, then minus 3i into 2 plus 3. Yeah, good. So Let's open this bracket. 7 times 2, 14. 7 times 3, 21. So 21i. So 21i minus 10i. Then minus 15i squared. Then divide everything. So 2 times 2, we're going to have 4. 2 times 3, we're going to have 6i. Then it's going to be minus 6i. This times it will be minus. Then we have minus times plus is going to be minus. 3 times it will be 9i squared. So let's continue from here. So we can have 14 plus 21i minus 10i. That should be 11i. So we have 11i. Okay, 11i then minus 15. You already know the I square is minus 1, so we just put minus 1 here, then divided by. We have 4. Then this from this will give you 0 to cancel automatically. Then you will left with minus 9i squared, which is what? Minus 1. So you have 14 plus 11i plus 15 divided by 4. Minus times minus is plus. 9 times 1 is 9, which is equal to, that's 14 plus 15, then plus 11 divided by, it has 15. So finally, you can have something like 29 plus 11 divided by 13. Okay, so you're going to be 29 divided by 13 plus 11 over 13. So that is simply the answer. I hope you understand. So let's go further. Let's go better. I want to do one expansion. Let me do one expansion. Okay. All right. Let's say that you have to expand something like this. Let's do this. You have to expand or express. So you have to express this 1 minus I or 1 plus I raised to the power of 4. So let's say you have to express this in, you have to express it in form of, so you want to express it as x plus y. This is a very simple question. You have to express this. What you do is that you are going to use binomial theorem to solve this. Although there are other method you can use, you can actually you can do it 4 times, like simply say 1 plus I multiplied by 1 plus I multiplied by 1 plus I multiplied by 1 plus I. You use to multiply this, the answer you get is to multiply this, the answer you get is to multiply this. See, but that method is very long. Okay, it's too long, so I'm going to use a short one. That's a short one that you can easily understand. It's very simple, so I'm going to use a very short one. Okay, let's go. It's very easy. So we're just going to use binomial expression, call it binomial theorem. So first thing is that you see this first, anything you have here, 1, say 1, then you raise to the power of 4, then plus 4 times this 1, which is going to be 4. Then you open a bracket into, what do you have here? You have 1. Then you remove 1 from this 4, that's going to be 4 minus 1, close the bracket, then multiply by this 1, I, then say divided by 1 factorial, then plus. This is going to be, of course, this is going to be 3. So which is going to be, you use that to multiply the denominator, the coefficient rather. So it's going to be 4, 3 times 4, then times 1, raised to the power of, this is now becoming 3 now. So you subtract 1 again, it's going to be 2. Then times, you have your I. So the power of I here is 1. So then the power of I here will now be 2. Then divided by, this is 2. Then it's going to be 2 factorial. Then plus this 2 multiply this, which is going to be 2 times 3 times 4 multiplied by 1. This is to the power of 2. You remove 1 from it, so it's going to be 1. And then times I raised to the power of 3. You add 1 to this one. So you're adding 1 to the power of I, and you're removing 1 from the power of 1 over 3 factorial. Okay. Then plus finally you're going to have 1 times 2 times 3 times 4, then times 1 raised to the power of 0 multiplied by I raised to the power of 4 divided by 4. Then you're going to, this is going to give you 1. Then this is going to be plus. Now this is, everything is going to be 1. 4 times 1 is going to be 4. Then I raised to the power of 1 is also I, so it's going to be 4I over 1, because 1 factorial is 1. Then plus 3 times 4, 12. 12 times 1, that's 12 I squared divided by 2 factorial is 2 times 1. So 2 times 1, that's 2 factorial. Then plus 2 times 3, 6. 6 times 4, 24. Then 24, that's 24 I cube over 3 times 2 times 1. That's the meaning of 3 factorial. Then plus 1. That is 1 times 2, 2, 2 times 3, 6, 6 times 4, 6 times 4, 24, then times 1, that's 24. Then we have a 24 I raised to the power of 4 divided by 20. That's 4 times 3 times 2 times 1. So now you have 1 plus 4I plus 2 in 12, that's 6. So you have 6, but your I square is minus 1, don't forget. Then plus 2 times 3 times 2 is 6. 6 divided by 24, 4. So it's going to be 4. What is I cube? I cube is minus 1, minus I rather, 24. Then I cube is minus 1. Okay, I'm going to show you how that be. Then plus, this is 4 times 3 times 2 times 1. That's 24. 24 divided by 24. That's 1. So we are going to have I raised to the power of 4. Okay. Then we have 1 plus 4I minus 6 minus 6 minus 6 minus 6 minus 24I. Then I raised to the power of 4 will be 1, of course. It will be plus 1. Then let's add 1 plus 1 is 2. Then 2 minus 6, that's minus 4. So we have minus 4. And 4I from 24I, that's minus 20. So we have minus 20I. So this is simply the answer. So I know some of you are asking me, like, how come? How did you know that I raised to the power of 3 is minus I? It's very simple. This is I raised to the power of 3. Now, this I raised to the power of 3 can be expressed as I multiplied by I squared. So this is going to be I multiplied. What is I squared? I squared is minus 1. So minus 1 times I will give you minus I. So that's how I know. Then also, if you have I raised to the power of 4, I raised to the power of 4 can be I squared times I squared. What is I squared? I squared is 1 times, what is I squared? I squared is minus 1. Sorry. So which is going to be minus 1 times minus 1 will give you 1. So that's how I know this what it's 1. All right. Let's quickly look at other things before we call it a day for today. Okay. Okay, so let's say we have to solve for the value of x and y. We have to solve for the value of x and y in the following. That's we have 3x plus 6i, then which is going to be minus 9 plus 2yi. So we have to here we have to solve for the value of x and y. Okay, so how do we do? It's very easy. Just solve for the value of x and y. Very easy. So just 3x plus 6i is equal to minus 9 plus this is going to be 2yi or i2y, whatever. So what you do is that you simply equate the imaginary numbers or the imaginary parts to the imaginary part and equate the real part to the real part. So let's start with the real part. So this is the real part here, 3x in this on the left hand side, and this is the real part on the right hand side. So well, let's equate it to each other. So we say 3x is equal to minus 9. That goes out like 3. It's easy. Then x should be equals to minus 2. So that's easy. That's your x. Then for the imaginary, we're going to say 6i equals to 2yi. This, we remove this, right? Then we have 6 is equals to 2y. We have beside by 2. And then y will be equals to 3. So pretty simple. Okay, let's take another one. Let's say that we have 9 minus 2yi, which is equals to 6x plus 8i. So 6x plus 8y. Very easy. Equate the real part to the real part and the imaginary to the imaginary. So by doing that, we can have 9 equals to 6x. Divide both sides by 6. Then x will be equals to. So this is going to give you, of course, 3 over 2. That's what you have. Okay. Then let's say that you have minus 2yi equals to 8i. So first, this I will remove this I, we cancel it out. You have minus 2y equals to 8. The other side by minus 2, the other side by minus 2. So you have y equals to minus 4. Simple, pretty simple. That's it. Okay, let's go for that. I hope you understand. Okay, so let's say that we have I into 2x plus 4y, then which is equals to 2x minus 4, then plus 3y. Okay, this is what we have to do. Very easy. You notice that everything here, this part here only has imaginary. It doesn't have a real part. But here we have this is the real part and this is the imaginary part. So what you simply do is that you equate this one to this one, which is going to be I into 2x plus 4 plus 4y. Yes. So 4y, which is going to be 3y. This we cancel this I. So we are going to have 2x plus 4y equals to 3y. Wow. Quadratic simultaneous equation. Then we just collect the like terms, right? So when we arrange 2x then plus 4y minus 3y, which will now be equal to 0. That is, if something is here and is moving to the other side, this positive 3y. If you have something like this, you simply take this y into that, or you simply subtract minus 3y from both sides. So you have something like that. So you have 2x plus y equal to 0. So you can call this one equation 1. Then let's solve the other one. Then you have the other one, which is going to be 2x minus 4 equal to 0. You can call this one equation 2. This is going to be 0 because there's nothing to equate it to. It's only just the new part, just on one side. So there's nothing to equate it to. Okay, then here we can see that 2x minus 4 equals to 0. Then you can see 2x equals to 4. Then next will be what? 4 divided by 2. So x is equals to 2. Then if you have your x equals to 2, you simply put 2 here. So it's going to be 2 into 2 plus y equal to 0. 2 times 2, you have 4 plus y equal to 0. Then your y is equal to minus 4. So you are putting 2 here. In this equation, you are putting it in 2x plus y equal to 0. So that's why this is where you are putting your 2. Because from here, your x is equals to 2. Okay, so finally, for today, so let's say that you have 2. So let's say that you have 2x plus y. Okay, so look at this. This is a very good example, and I believe this is going to lead us to simultaneous equation. So this is the real part of this equation, and this is the real part on the other side. So you equate this one to this one. So this is going to be 2x plus y equals to x minus 2. Then you have 2x, collect the like term minus x plus y equals to minus 2. That is simply subtract minus x from both sides. So you have x plus y equals minus 2. Equation 1. Then other ones, then you equate this one to this one. You have 3x minus 4y. You have this. Then you have 3x minus 4 equals to 4y minus 5. Then you have 3x minus 4y minus 4y equals to minus 5. Then you have 3x minus 8y equals to minus 5. So you can, so that's simultaneous equation. So from equation 1, you can get from equation 1, you can simply say that x is equals to minus 2 minus y. That's from equation 1. Then you put this one equation 2. Then you put equation 2, or you can simply use your calculator if you have calculator. There are calculators that solve this better. So you can use calculator, but let me just solve it for you guys. Now, so you are going to have 3x minus 8y equals minus 5. So anyway, you see x, you put minus 2 minus y minus 8y equals minus 5. Then there's minus 6 minus 3y minus 8y equals to minus 5. We have minus 6 minus 11y, which is equals to minus 5. We have minus 11y equals to minus 5 plus 6. Very simple. We have minus 11y is equals to 1. Then y will now be minus 1 over 11. That's your answer. So you simply divide both sides by minus 11. Then you come here and say that x is equals to minus 2 minus y. So what is y? Y is minus 1 over 11. X will be minus 2 plus 1 over 11. Then you find the LCM. 11 will be the LCM. So here you're going to have that x will be 11. 1 dividing 11 is 11. Multiplied by minus 2, that's going to be minus 22. And plus 11 divided by 11, that's 1. 1 times 1. So this from this is going to be minus 21 divided by. So that's all. Okay. Okay, guys. So that will be all for today. Thank you and see you tomorrow.